record, view, full screen. Can you read out the question to me, Sarah, please? It's
1 plus sin x.
1 plus sine t or sine x, whatever, yeah, over cos x. And then it's again, but just upside down.
Minus 2.
Okay. So if I multiply these together, I'll get cos plus cos sine, because it's cos times 1 plus sine. And on the top, I'd get 1 plus sine times 1 plus sine. So that's 1 plus 2 sine plus sine squared. And then cos times cos, that's cos squared. And then if I want, I can also put this in as well as over 1. So that could be minus 2 cos minus 2 cos sine equals 0. Cos sine. So if you're a little bit confused, what I did was here, I just rewrote that as 2 cos plus cos sine over cos plus cos sine. And the reason for that is the denominator will be the same as this, so you can combine them together. So in other words, I just put all three fractions together as one fraction. Something you learn how to do in middle school for sure. So if you look at the top, sine squared plus cos squared is 1. And then there's another one here, so that's a 2 plus 2 sine minus 2 cos minus 2 cos sine all over cos plus cos sine. Now,
could be factor 2.
Yeah, I can divide everything by 2. So on the top I get 1 plus sine minus cos sine all over cos plus cos sine equals 0.
I'm sorry, what did you do in the second step?
Divide everything by 2. You mean from here to here?
Yeah.
Yeah. Divide everything by 2. So that's a 1, a sine, a cos sine. And I'm going to change the denominator back to cos times cos plus sine. Okay, that's kind of a bit simpler. If I look at the top, say again? Yes? How did I change what?
The denominator back to.
What do you mean?
1 plus
Oh, sorry.
1 plus
Sorry. I'm wondering if this would be better as sine squared plus cos squared. Don't write the next part down, okay? Because I'm going to see if it'll work first. Sine squared plus cos squared. So if I write it like that, I have a sine squared here, a sine here, a sine here, a cos here, and a cos here. So I could factor out sine, and I'd be left with sine plus 1 minus cos. And in this one here, that's sine, that's it there, and that's, well actually, I think I'll leave that one alone. And then what I'll do is I'll take cos out of cos from here, here, and here. So I get plus cos, and then this one here would be a cos minus 1 minus sine. You see, I'm getting really close to getting a sine plus 1 actually. So what I'll do is, rather than taking a cos as well, I'll just put the cos at the end. I won't do anything with that cos. And I'll take the minus out here. So that would be a plus and a plus. Okay, so let's just see if that matches up. Sine times sine, sine squared. Sine times 1, sine. Cos times 1, minus cos. Minus cos times sine, minus cos sine. And then, oh, did I already account for this here? Let's double tick it off. Sine times sine, sine squared. Sine times 1, sine. Cos times 1,
cos squared.
well, minus cos there.
It's this.
Minus cos times sine. Oh, so I don't even need this here, sorry.
We don't have cos squared.
Oh, so, sorry, so I do need it there. Okay, but I can see there's a sine plus 1 in common to these two. So I get 1 plus sine, and then sine minus cos, plus cos squared, all over 1 plus sine. And actually I'll change cos squared back into 1 minus sine squared. But 1 minus sine squared can be written as 1 minus sine times 1 plus sine. Now, what's in common to everything? 1 plus sine. So as long as 1 plus sine does not equal 0, we can cancel this, this, and this. And at the top we're left with sine minus cos plus 1 minus sine. So on the top we're left with sine minus cos plus 1 minus sine. Well, minus sine and sine go all over cos. So cos can't be 0. I can bring it up here if it's not 0. So you're left with cos x equals 1. So therefore, what's the answer here? Cos inverse 1 is 0. 0. Or 360. So that's the first answer, or the second answer, which is the same as the first answer here. And how do we make extra answers? By adding 2n pi. So in other words, there's all the answers there, 2n pi. Can we check that this is right? So pick a number for n, let's say 20 or 10. So that'll be 20 pi. So can you type this in here in radian mode, x is 20 pi, and see if you get 0. Thanks. I'll check too. You check as well. 1 plus sine 20 pi yeah, so you do get 0. You'll end up getting 1 plus 1 minus 2. So I'll scroll down to where you need to start writing, which was here.
You don't understand the section.
Huh?
I don't understand the section.
Again, I need specific questions.
From like the first line.
First line on the screen? To what, the second line?
Yes.
This is a very difficult question. In fact, too difficult for the exam perhaps. But I don't want you to worry about it, because the next lesson which we're going to do today, it will help support this lesson here. Well, I can't really say for this question here, start here, do these things, and then you end up here. I can't say that, because if you remember earlier in this question I said don't write this down because I don't know if it'll work. So with these things here, it's just a matter of writing it in different ways to see if you can simplify it. There's no one strategy I can take. Do you remember earlier I changed this 1 here into sine squared plus cos squared? Maybe that wasn't the right thing to do. Maybe you shouldn't have done that. You don't know until you try and see if you can simplify it. The reason I felt I should change the 1 here is because everything else has a cos or a sine in it. So I thought if I could get this looking like the rest of it, maybe there'd be something I could take out of everything. And there was. But the thing that I ended up taking out was actually something difficult. I was able to divide by 1 plus sine. And then I realized, but there's no 1 plus sine here. But then I thought, but you can change cos squared into 1 minus sine squared, which is almost 1 plus sine. And then you have to remember the rule from semester 1, x squared minus y squared equals x plus y times x minus y. So I'm sorry, there's no strategy here other than intuition, which I realize isn't a strategy. Do you know what I mean when I say intuition? Some people know this word. Some people don't know this word.
Question?
Intuition.
Like something, common sense.
I wouldn't even say common sense.
I feel like I can win something.
Kinda. Yeah. Just have a feeling about what to do. This, I realise, is no good to you if you're confused. But what can you do?
Scroll down.
Too far? Go here. Further.
No.
No, I think I agree with the rest of the class. I'm sorry. I'd scroll to here. Maybe you can try the last two again. Not now, but later. And remember I said maybe you could try replacing the 1 with sine squared plus cos squared? Yes? Also, my other bit of advice is that I do know the double angle formulas will appear. So when you replace the 1 with sine squared plus cos squared, you should also be trying to make the double angle formula appear. If this was in the exam, what they would do is they break this question down into steps. So step 1, actually yes, that's a good point, so I should say that. Can you all listen? If this was in the exam, okay, what would happen is they might say something like, step 1, show that this here can be written as this here, as cos x. Now, the advantage of that is when you know what you're trying to get at the end, it sometimes helps guide you in what way to go. But the other advantage is, even if you couldn't do it, you could still do the second part of the question, which was then solve the equation, because you know that this can be simplified as cos x, okay? So if this did come up in the exam, it would be broken into parts. And if you couldn't do one part of it, like the show part here, that's not the end of the world. It just means you lose marks for that part. Okay? Yes?
What happened to sine and cosine?
Where?
This step, exactly. What do you
This one here?
Yeah.
Divide everything by 1 plus sine.
Oh.
It's in everything.
Then how did you get minus cosine plus 1? You have the sine.
Ah, but then here, this is a sine and this is a minus sine. Then they cancel.
Thank you.
Section A question.
Oh, no. That would never be a section A question. Never. Section B for sure.
Sorry, could you scroll down?
Go down now, yep. We have one other class later today. We'll actually get trigonometry finished today. And then we start the next chapter. Now it'll be vectors, then back to calculus. But don't worry, the topic later today is trigonometry and calculus. So don't worry, okay? Okay,
When are we going to take statistics?
that'll be at the very end.
And aren't you going to
No. We have after this, later today later this week we'll start vectors. Then we'll do calculus again, and then we'll finish with statistics. So we'll gently ease down at the end with statistics. Yeah. It's like a therapy, tense workout, and then at the end you just wind down a bit of statistics. Couple of bar charts, a few averages, relax. Yeah. Okay, now next topic. This does not come up too much in the exam, okay? I think I've seen it maybe 2 or 3 times, so it's not so common. But all of these, they ask you to prove or to show some result. So for example, firstly I should say, in the exam for these proofs, you can only use the rules in the formula book. So what would happen is they give you some rule. This is new now. They give you some rule, and you can only use the rules in the formula book to prove that it's true. Okay? For my worksheet today, you can only use the compound angle rules and the sine squared plus cos squared equals 1 rule. However, as you go down the page, if you prove something earlier that you find will help you later, you can use that. Because it's almost like you can copy that proof and stick it into the later question. Okay? So, for example, the first question is, I ask you to prove that 1 plus tan squared x equals sec squared x. Now, there's two ways you can do these problems. The first way is you can start off with 1 plus tan squared on the left and then try to simplify it into what's here on the right. That's one way to do it. Or of course you could start at the right and try to go to the left, or you could take both together. So let's do it firstly by starting at the left. So what can we say tan squared is? Sine squared over cos squared. Now if you pause for a moment, we're trying to get one term. And how many have I got here? I've got two terms. So the logical thing next to do would be to add them together to make one fraction. And then we have cos squared here plus sine squared here. But what's cos squared plus sine squared? 1. And what's 1 over cos? That's sec. 1 over cos is sec. Secant. Yeah? So 1 over cos squared is sec squared. So you're finished. You managed to start here and show that you can simplify it into this.
What's 1 over sine?
Cosec. Here, Abanu, to help you out here, this is how I always remember it. The letters are always opposite. So 1 over cos is sec and 1 over sine is cosec. Now, the second way to do it would be to start with both and simplify it into something that's obviously true. So you have 1 plus tan squared equals sec squared x. What's tan squared? It's again sine squared over cos squared. And what's sec squared? It's 1 over cos squared. So if you want to cancel the denominators, what do? Multiply everything by cos squared. So you get cos squared x plus sine squared x equals 1. Now is that true? Yeah. So the second way to do it is to take the whole equation and to simplify it together until you end up with something that is known to be true. The third way to do it is probably the most difficult way, is to start with sec squared and to get to 1 plus tan squared, which would be literally starting here and going backwards, which I won't bother to write down because it is going to be the mirror image. This is more difficult to do. My advice is it's usually easiest to start with the bigger side and reduce it rather than to start with the smaller side and expand it, usually. Okay, so make note of that. We'll look at a more complicated one next, maybe.
Did you just scroll down?
Oh, sorry, there's a little bit at the bottom, yeah. Okay. Next example. So that's the first example. Next example. Show that sine pi over 2 minus x equals cos x. So for me, what do you think would be the easiest one here? To start at sine and go to cos, start at cos, go to sine, or take both together? I think sine to cos. So what rule can I use here for sine pi over 2 minus x? What rule could I use? Sine a minus b. Yeah? So this will be sine a cos b minus sine b cos a. Now, sine pi over 2 is 1. And what's cos pi over 2? It's 0. So you're left with cos minus x. But this looks wrong, because what should we have? We should have cos x. Anybody know how to fix it? Not multiplied by minus 1. We have shown sine pi over 2 minus x equals cos minus x. What's wrong, Faisal?
Oh, why did you put the minus x inside sine minus x?
Yeah, why did I do that actually? That was stupid. Actually, what I did was also right, because if you have a minus x, you can actually delete it because cos is an even function. Sorry, Faisal, what I actually did in my head for some odd reason was I did pi over 2 plus minus x. It's like, oh. So sorry about that. Yeah, so there is no minus there. But anyways, even if there was a minus, that's perfectly fine because cos is an even function. So remember, cos x equals cos minus x. They're the same thing. So it actually wasn't a problem anyways. And we're done. Yes, Precious? No?
Still?
Yeah.
Can you go over that one more time?
Yeah. So what rule I used here was sine a minus b is sine a cos b minus sine b cos a. But cos pi over 2 is 0, so that's deleted. So you're left with sine pi over 2 and cos x. But sine pi over 2 is 1, so in fact you're just left with cos x, which is what you want. I'll do one more now. Okay, so next one. Show that sine squared is equal to 1 minus cos 2x over 2. So which is the easiest approach do you feel here? Go from sine to cos to sine, or take both together? Cos to sine, I think. So if we start with the right, 1 minus cos 2x over 2. Now you've got to remember this is a double angle, or in other words, it's the same as cos x plus x. So you can use your compound angle or your double angle formula here. Who remembers what cos 2x is? Very good. It's cos squared x minus sine squared x. The reason for that, if you remember, is it'll be cos x minus sine x. So what do you think we should do next? Well, I think this 1 should be changed. Sine squared x plus cos squared x minus cos squared x plus sine squared x all over 2. What happens to the cos squareds? They go. Sine squared plus sine squared. 2 sine squared over 2. Which is what they ask you to show in the question. So again, that one's done. You didn't write the question down? No. We can't have that nonsense now. You need to keep up. You can write the question down from your neighbour. The ones on this worksheet, I think none of these do. Possible exception might be the one I did at the very start. You know what? Let me open up the formula book, because I said I'd do that last time and I forgot. Don't worry, I'll put the answer back up now. Let's see.
Why didn't you put 2 sine x squared?
I did, and then over 2, so I didn't bother to write that down. Let's see. Formula book. There we go. All right. That's the calculus rules. There's the vectors, trigonometry. Where are you? Trigonometry is E and J. Right, so the formulas you got is your classic sine squared plus cos squared equals 1. You also got the cosine rule, which actually you don't need because that's in semester 1. You got your sine rule, semester 1. You got your double angle, and you also got your compound angles. Okay, so you got double angles and compound angles. So yeah, none of these, Brendan, should be in the formula book, and you should be able to try and prove them all using sine squared plus cos squared, compound and double angles. Okay, sorry, I'll go back to the answer now. Does anybody else want to see anything in the formula book while I have it open? Will we just have a quick run through it? So everything from semester 1 is in it. So that's A, B, C, D, E, and F is all the same. And then your derivative rules are there now as well. Your product, quotient, and chain rule are there. Your integration rules, your integration by part. And if you recall, these appear differently in different formula books. The way I used it in class is using F and G, but I also showed you how to use it using U and V. You got your area, which is here. You got your volume, which is here. You got your vectors, which we're doing later today. And then your second calculus called numerical methods, which is after the vectors. And then, like I said, the formula book finishes with the last chapter as well, which is the statistics formulas. Okay. Do you need to finish writing this down? Yeah. What's wrong?
So, would we be asked to show an equation equals 2, like if an equation equals secant and another function, instead of just one function?
Yeah, that could happen. I mean, these don't come up too much, but they can really ask you to show any possibility. So they could say, sine squared and cos squared show that they could equal, secants and cosecants. So it could be more than one. I know in my example I usually have just one term, but it could be more. It could be like show that this plus this equals this plus this. Yeah, that could happen.
Would it be the same method or a different method to solve it?
Yeah, like I'd say if you had something where you had like on the left sines and cosines and tans, and on the right you had secants, cosecants and cotans, for me I'd feel it'd probably be easier to start with the secants, cosecants, cotans and simplify them into sine, cos and tan. It really depends on the question. It's not always clear. And in fact sometimes it's just whichever way you prefer to do it as well. So I feel like the easiest way is to start with the bigger side and go to the smaller side. Alright, see how many of them you can do.
1/10 is cosine.
Sure is. Do I actually have everybody here? Complete set?
It's a day to remember.
Yeah. Everyone's present day is today. It happens exactly twice per year. Once at the start, and then at some random point in semester 2. You know, when the moon is right, star signs are good. Well, this looks like everybody, they have only one left. Yes. Well, you can see some of them look very similar. So what I recommend is try to do one of each type. So if you look at that, you can do like, for example, one from A or B, and then you should do one from like C, D, and E, and then you should do one from F, G, and H.
Okay, one simple square.
Yeah, so like pick one of each category. Yeah, just let me pause or stop this here.